Howdy. Are you struggling to make your code instantly clear to you and your team?
So, picture this. Your code is solid, it does the job, but it's basically unreadable to anyone else. And hey, a new colleague is about to start.
You're learning to code, but now you have to learn how to document too. Yep. The good news is you get more benefit in Elixir because documentation is a first-class citizen. Welcome to today's exercise, City Office. We're getting you started with 4 module concepts that document different kinds of metadata about your code. In this video, we use AI tools to teach us exactly how to implement module documentation, function specs, and even define custom types. Let's master this concept and elevate your Elixir code quality.
You were supposed to remove the red, not add more.
We have enhanced the color palette as requested.
I want to tell you how AI fooled me with its enthusiasm to complete my requests. I was struggling to get a prompt working accurately and reliably. I kept getting responses that included extraneous or irrelevant information. And then it finally dawned on me that most AI agents can't actually read the exercise pages since they are only available when you're logged in. Gemini told me that it was essentially parsing the URL and then using that to get information about the exercise from other sources. So now I provide a PDF of the exercise page with my prompts instead of a URL. With my new and improved prompt, I've generated a NotebookLM explainer video, and I'll include snippets of it to assist in explaining Elixir concepts.
Welcome to the explainer. Today we're going to jump right into the Elixir exorcism exercise called City Office. We're going to see exactly how to take some functional code and make it truly clear and professional.
I've downloaded the City Office exercise using the exorcism CLI, and I've fired it up into VS Code. This is normally where I'd reach for our prompt to bring in the documentation, but on account of that being the point of the exercise, we'll do it by hand. So we'll have to bebop back and forth between the README and the source code.
With @moduledoc and @doc, you write your explanations right there in the code. And this is so powerful, right? It means your documentation isn't in some separate file that's going to get outdated in 5 minutes. It lives and breathes right alongside the code it's describing, starting from the very top with task number 1, documenting the entire module.
So first things first, we need that big picture view. We use @moduledoc right at the top of the file to leave a simple 1-sentence summary. Just a little note that tells our new colleague, hey, this is a bunch of helper functions for City Office forms.
The module doc typically comes at the top of the module, very often the first thing after the declaration.
All right, now that we have the overview, it's time to zoom in. Let's tackle the next 3 tasks where we document the individual functions.
So task 2 is about this function called blanks. The documentation needs to explain a quirky little rule at this office. You can't have empty fields. You have to fill them with blank spaces instead. It's those little details that really help people out.
And here's the spec for it. It's super clear. The function takes one argument, a non-negative integer. And that double colon you see there, that just tells us what it's going to give back, which in this case is a string.t. The contract is perfectly clear.
One thing to note, the test is pretty particular about the formatting. So this says, well, that's true, but I'm in front of the wrong function.
Now you might be thinking, but Elixir is dynamically typed. And you're right, but that's what makes @specs so cool. It lets us write a kind of contract for our functions. And it's not just for people. Tools like Dialyzer can actually read these specs to find bugs automatically. It's a huge win. And to write those contracts, you'll be using these bread and butter types all the time. You've got your basic string.t, integer, list, and so on. Getting comfortable with these is really the first step to writing crystal clear specs.
Next up for task 3, we're looking at a function that takes a string and splits it into a list of uppercase letters. You know, for those forms that have 1 box per letter. Another weird office rule that needs a quick explanation.
And the type spec for letters is just as straightforward. It takes in a string.t and gives you back a list where every single item inside is also a string.t. Anyone looking at this knows exactly what to expect.
in this case, the list of strings, it's being represented by the square brackets.
Okay, task 4 is all about validation. We have a function that checks if a string is too long for a particular field, and if it is, it'll even tell you by how much. Pretty handy. Now check this out, because this return type shows off a super common and really powerful pattern in Elixir. The function can return one of two things. It can return the atom OK if everything's good, or it can return a two-item tuple that looks like @error some number. This is fantastic because it makes whoever uses this function deal with both success and failure. No surprises.
Error, and the second one is a positive integer, not a non-negative integer, so that's pos integer.
All right, moving on, we're going to tackle something you'll see all the time in the real world, dealing with more complex data structures, like a mailing address. For task 5, we get to create our own custom types. Think of it like building your own Lego bricks. We use @type to define two different ways to represent an address. One is a map, one is a tuple. Then, and this is the clever part, we create a third type called address that can be either one of them. That makes our code way more flexible.
To declare a type, you use the @type module constant. We want an address map. That looks good. It's got 3 properties, a street, a postal code, and a city, all of which are strings. Oh, address type tuple. All right, well, that would be correct, with the exception that the instructions want labels on these. And then we want the address, which is either a map or a tuple.
And for our very last task, we're documenting a function that takes one of those address types we just made and formats it into a nice, clean, multi-line string.
And boom, this is where all that setup we did pays off big time. The type spec for format address is so simple. It just says it takes our custom address type. Anyone reading this immediately understands it can handle both the map and the tuple we defined. It's just clean.
Then use the address and the format address function. Takes an address, returns a string. So @spec, format address, takes an address, returns a string. Add the doc.
All right, we made it through all the tasks. Let's just take a second to do a quick recap of what we just accomplished here. So what's the big takeaway? You've basically just mastered Elixir's 4 essential tools for documentation. You're not just writing code that works anymore. You're writing code that communicates, code that's easy to maintain, and code that your teammates, and let's be honest, your future self are absolutely going to thank you for.
And that's how you go from undocumented code to professional grade, crystal clear Elixir by implementing powerful custom type specs and thorough documentation. Hit the like button if you learned something today, or to let me know that you simply enjoyed the video. Subscribe for more idiomatic Elixir and AI workflow tricks. See you next time.